Here it goes. All right, so the first problem you had the number of molecules in 250 grams of water is. So you had to figure out, I kind of already had it circled and underlined from first period, but so hopefully you use that to your advantage. So the starting point is always where the number is, right? So our starting point was the 250 grams right here. Okay, so that one was circled. So we started on your map in gram land, right? And we needed to get all the way to, what does molecules fall under?
Particle city.
Particle city. It's a funny chemistry word. That's the way I always think of it. If you have any funny chemistry word that shows up, it's probably particle city. Okay, so you're going to particles. But one thing that we covered on Friday was the fact that you have particle city up here, you have Gramland down here, Moletown in the center, and Volumeville over here, right? Oh, you can't see any of that. That's okay. Sorry. And then volume over here, okay? And so there are routes from Moletown to all of those places. You cannot just skip and go to Particle City directly. You have to travel through Moletown, right? So you have to go this direction. So we do have to hit moles on the way, all right? And so that should have been the way that you set it up. All right. Now, I am not going to use the map. That is meant for you. Remember, I told you I will only teach it showing you dimensional analysis, meaning you're canceling out the units, the math part of it. But you can always use that little map to kind of help you with the setups. So make sure you use that to your advantage, okay? You have it next to you. All right, so me looking at this, I would say, okay, I'm starting with 250 grams. Of water, you would solve for it just like you did on the first night's homework. Okay. We would bring all of those words down to the right, okay? So I would have grams of H2O. I know that I have to go through the mole, so I know that's what has to end up on top. Whatever I want has to end up on top, right? So this little conversion, just like all of the conversions, is always talking about how many moles. 1. It's the definition of a mole, right? All of your conversions that you use for this unit, which leads us into stoichiometry, the converting part is the definition of a mole, which is always 1. All right? So we're going to say 1 mole of H2O. The definition relating to mass is the molar mass of something. So you needed to use your periodic table and add up 2 hydrogens plus an oxygen.
The molar mass is 18.
So you should have ended up with 18 point what? I had 015? Okay. Good. Sweet. That's a lot of happy people. All right, cool. All right. So, let me see if I can erase this real quick. I'll do that in just a second, okay? All right, so the next step is now we're going to take the moles, we're going to bring that down to the right. I'm going to do it all in one step. You could do it in 2 pieces. There's nothing wrong with doing that. If that makes more sense to you to keep them small, that's fine. I'm going to do it all in one step because that's what stoichiometry is going to look like later. So I'm going to bring moles down to the right. So I'm down to moles of water. So I'm just following math rules here, right? And I know that I need to get to molecules or particle city. So I'm going to put molecules on top, not to be confused with the mole. It's a different unit. Okay. Once again, we are answering the definition of a mole, 1 mole. And if we're talking about counting up things, it's like me saying a dozen eggs, right? We're going to say Avogadro's number for this one. So this is, yep. Perfect. 6.02 times 10 to the 23 molecules. Okay? Okay. So now comes the part where you have to type it into your calculator, which is what people do struggle with. So I'm just going to write this off to the side. Make sure you're practicing it if you didn't practice this over the weekend at all. Okay? And so you would type in 250 for this. You would hit multiplication. 1 times, and then 6.02, you would type in second, that x to the negative 1 with the EE on top, 23, and then I would push equals. Okay? And then you would hit divide 18.015, divide again by 1, and then push equals. And then that should get you your answer. And you should have, oh, real quick, let's check our sig figs. How many sig figs should this answer have?
3.
Should have 4. You were correct. 4 sig figs, that both those zeros count. Trailing zeros with a decimal count. All right, so then our answer would be 8.354 times 10 to the 24 molecules.
Would we get the 250 from this?
Okay, hold on. Okay, so to keep going, looking at number 4 isn't as bad, but it does teach you something to pay attention for, or pay attention to, right? Well, it is a gas, but do we really care about anything having to do with Volumeville right now? Is anything mentioned in liters there? No. So what I want you to do is not be scared if you see the word gas. The whole point of Volumeville in your little map, where I said liters and only has to do with gas, it's only if I'm asking you for liters or if I'm asking you for the volume.
And this is grams.
Yes. Okay. Or if I wanted, or if I gave you grams and you needed, no, actually no. It's just if I mention liters. That's really all you need that for. That's not going to be important to you. You'll know which question that is. Okay. So on the homework, I know some people kind of stopped on that one. So this is just a gram land. So grams to moles. The part that you have to be careful with is the fact that it is hydrogen gas. Yes, it's because how do we represent hydrogen gas in a balanced equation? H2, it's a diatomic. So you have to make sure you respect that when you're coming up with that molar mass. That's the part that you need to pay attention to. Any of your diatomics, if it's in a gaseous form or whatever, you got to go ahead and put that little 2. So the way to get through this one, let me just speed you through it so we can get to the notes for today. We have 5.00 grams of H2. I brought my words down to the right, and I need to get to moles. So we know that the definition, or the thing that relates moles to grams, is that 1 mole is the molar mass. Well, this one has 2 hydrogens, so it would be 2 times hydrogen's molar mass from the periodic table. So you get 2.016, and that's what I'm going to put here. So this is just 5 times 1, push equals, divide 2.016. That's your calculator stuff. So you should have ended with, the answer of 2.48 moles. We wanted 3 sig figs. Okay? All right. Okay. So percent composition is not overly stressful. Sorry, mine is really blurry up there, but you have it in front of you. So percent composition, we actually did kind of something very similar to it when you guys did the lab where you had to separate the iron fillings from the sand and the salt. And you guys had to make me a little pie chart that said, hey, there was this much sand, this much salt, this much iron fillings. Well, we're doing basically the same exact calculation where we do part over whole, except we're focusing in on compounds that have the little subscripts. So when we think about something like water, I think it's talking about that in the little description right here, right? So if I have my water molecule, just because there's 2 hydrogens, does that mean that hydrogen takes up most of the percent of the mass? No, because who's heavier? Oxygen is, right? So because of these different molar masses, they actually take up different percentages. And so what's going to happen is we're going to be doing it going in this direction where I give you a compound and you tell me percentages to lead you up to me saying, hey, we found this mystery compound. Its percent by masses is this. So there's 72% of that and 28% of something else. what's their actual subscripts? You're going to be able to take that information to figure out the compound name, all right? So, so this is to just kind of prepare you for what's coming, which is using those percents to figure out things, which is actually what scientists do in the lab, all right? So we can do an analysis of combustion to figure out what fuel we were actually using, all right? So we'll see some of those later. All right, so when you're trying to do that, you always want to start with, so I'm just going to put some little numbers in their little example up there. You want to start with finding the molar mass of your entire compound. That's always useful. Then you would find the mass of the element in 1 mole of the compound, which means you need to have times the subscripts, or multiplied by subscripts, right? So we got to consider the fact that there's 2 hydrogens in that water molecule. And then finally we have to multiply things by 100 because percent means out of 100, right? In order to get that. And so in our examples, you'll kind of see different ways to do that, or the different ways that this problem gets applied, and so you just gotta kind of be ready for all of it. And that'll be what your homework is tonight. All right, so for the first example that we've got, it says find the percent composition of copper 1 sulfide. So real quick, you have Cu2S right here. Where is that 2 coming from? Sulfur has a what charge? A -2 charge, right? And then copper had a what charge in this one? A 1, which came from the Roman numeral. So just to continue reviewing that, this is where all those subscripts came from, crisscrossing. Okay? All right. So when we go to find the percent composition of this, we're going to start with the first part, which would be, let me kind of zoom out a little. Find your molar mass of your entire compound. So we're going to get the mass of copper from our periodic table, which is 63.546. How many coppers are there? 2. So I'm going to multiply that by 2, close some parentheses. That way it makes sure that it handles that multiplication first. And then I would add it to the sulfur, which is 32.066. So we just found our total molar mass. And looking at this calculation, it is an addition problem. So how do I determine what my answer should have? Number of decimal places. Good. So how many decimal places are there going to be in this answer? 3. So our answer is going to go to the 3rd decimal place. So you would end up with 159.158 grams. And this is technically, since it's a molar mass, we could say grams per mole. What'd you say?
If you put that in the calculator, will it come out like that? The answer?
You can try it.
Okay.
All right. So first we got our molar mass, right? Now we're going to go and figure out the masses of each thing, right? So a good habit to get into is make sure you label your calculations. So I'm going to say percent of copper will be the first thing that I'm solving for. Percent of copper. So we're going to say 63.546 times 2. By the way, does this 2 make it 2 sig figs or 1 sig fig? No, you never do whole numbers like that, okay? It's all based off of this guy right here, just so you know. All right. And for this, I'm going to give you a whole new rule for percentages, so don't even worry about sig figs right now. All right, so we have that for the top number. We're going to divide it by our total molar mass. So there is part over whole. Okay. We're going to get a number. You're going to get about 0.7985. And we take that and we have to make sure we do what? Multiply by 100, which is not 3 decimal places, it's 2 decimal places. decimal places. Wow, I cannot say that. All right, so you're multiply by 100 to move that to the right. So you would end up with 79.85% copper. Okay, so a couple things that I want to make note of, and you might add this to the top of your page. Okay, for percentages, I just want 2 decimal places for your answers. All right, so percentages, we usually just go to 2 decimal places. Keep it simple. Don't worry about sig figs, they get crazy. Okay, also, a couple people were saying instead of doing this times 100, can't we just move that decimal place? Absolutely. Anything times 100 means you're going to take that little number and you're going to move the decimal 2 to the right. So if you want to add that little thing underneath the times 100 step, you can do that. And that saves you an extra calculation.
That step you just did, that's number 2, right? Or is that still number 1?
We're still in example number 1. Oh, no. This is step number 2, yes.
Okay. Just
Sorry, my bad. I forgot to put that.
That's okay.
Okay, any other questions? We're all good? Keep going? All right, let's get sulfur. So, now we're going to do sulfur. So, percent sulfur is going to be 32.066 on top. Divide it by that total molar mass. Oh my goodness, I forgot my 1. There we go. All right. So that's 159.158. Sorry, I know it's not very clear. There you go. All right. So we're going to do that. And we're going to make sure that we are multiplying it by 100 or moving that decimal. Because you would have gotten 2015. So I multiply it by 100. And I get 20.15%. I think you actually get 20147 in the calculator. So just know that this 5 is coming from rounding. Okay? All right. So now we have the percentages. This is us finding the percent composition of the whole thing. You found each piece. All right? And a good checking point is making sure they add up to be 100. That's around 100. Okay? All right. So go ahead and you look down at example 3. We'll come back to example 2 in a second. You should be able to handle example 3 on your own. Example 3 says, find the percent composition of silver in silver nitrate. So I want you guys to do example number 3. I'll put the answer up here, and then you guys can check your answers on mine. So the first thing you should have done was found your molar mass. I kind of showed all the work up there, so make sure you're in the right step. And then it's just asking for percent composition of the silver. So go ahead and finish that up, and I'll have the answer up here in just a second. There you guys. There you go. You only need to do the one side that says percent composition. Thank you. No, this one should make everyone feel better about life again. And then tomorrow we'll go back to the miserable thing. Hydrates are not it.
Why do we keep using 100? Like in all three?
Because it's a percent.
Oh, that's
Yeah. You're good. That's why if it's easier, just move that decimal 2 to the right. Just at the end, always move it 2 to the right. Yeah.
I was thinking, I was looking at it, I was like, wait, why are we using 100 for every single one?
Yeah. All right, sorry guys. Let me just add this other thing to the recording, and then I will put it back on the other screen. So your homework tonight is just to complete the side that says percent composition. Again, just like the homework from the weekend, if you don't have a calculator, show all your calculations, and then you can plug things in tomorrow during class. Sorry.